Okay, we're going to go through this optimization question together. ABCD is a rectangle such that A and B are points on the graph of this y equals the square root of 1 minus x squared, and C and D lie on the x-axis. Okay, so we want to write an expression for the area of ABCD, so we need to know what this looks like. If we look at our equation here for our function, if you square both sides of the equation and then add the x squared, you have x squared plus y squared equals 1. Which is standard form for the equation of a circle with radius 1 that's centered at the origin. Now we're only dealing with the top half of the circle though, because we only have the positive square root. Okay, so this is a semicircle centered at the origin with radius 1. So there's our function. And now what we want to do is take a rectangle and inscribe it into that semicircle. So if we take this rectangle here and place it right there, we have our points A and B on the function and our points C and D on the x-axis like it says they should be. Okay, so we want to write an expression for the area of this rectangle. So we know that the area of any rectangle can be found by doing length times the width. Okay, so for the length of this rectangle, we know that from the origin out to point D, well, that's a distance of x. So the entire length of the rectangle is going to be 2x. Okay, and then for the width, or the height, if you prefer to think of it that way, we go from point D up here to point B. Well, that's the distance from the x-axis to the function, so that's a distance of y. But we know that y is the square root of 1 minus x squared, because that's our equation for the function, so we can substitute that in for the width of the rectangle. So we have 2x times the square root of 1 minus x squared. Okay, and it said to write an expression, not an equation, so we really just need this for our answer. Alright, so we're done with part A. Part B, find the exact value of x when the area is a maximum. Okay, so this is an optimization problem. We're trying to find the maximum area of this rectangle. So we know that a maximum or a minimum is going to occur at the stationary points, which is when the derivative of our function equals 0. So when the derivative of the area is equal to 0. That's where our maximum is going to occur. Okay, so if we look at our area equation down here, let's rewrite that as 2x times the quantity of 1 minus x squared to the 1/2 power, and now we'll use the product rule for our derivative. Okay, so a prime equals the first function times derivative of the second function, which is 1/2 times the quantity of 1 minus x squared to the negative 1/2 times negative 2x, derivative of the inside piece. Okay, plus our second function, 1 minus x squared to the 1/2 power times 2, which is derivative of the first function here. Okay, so for the maximum, again, that's going to occur when this derivative is equal to 0. Okay, so now we need to solve this equation for x. So if we look here at our first term, these 2's are going to cancel, and we have this other negative 2x here, so our coefficient, we have negative 2x squared. Let's move this quantity back down to the denominator. 1 minus x squared in the denominator. Okay, and then we have plus 2 times the square root of 1 minus x squared here equals 0. Okay, so now let's move this second term over to the right side of the equation. So we'll have negative 2x squared over the square root of 1 minus x squared equals negative 2 times the square root of 1 minus x squared. Okay, let's see if I can get some more room here. Okay, so our negative 2's are going to cancel out. And we can multiply both sides of the equation by the square root of 1 minus x squared, so then we get x squared is equal to 1 minus x squared. So 2x squared is 1, so x squared is 1/2, and x is plus or minus the square root of 1/2. So x is plus or minus 1 over root 2, or root 2 over 2, if you prefer to write it that way. Okay, so now if we look at our equation, we got both the positive answer and the negative value here for x. right? But we're talking about area and distances, so we want x to be positive because it represents, well, it's representing half of the length here of this rectangle. So our x value is 1 over root 2. Okay, so that's the exact value when the area is a maximum. Okay, so for part C now, it says find the maximum area of the rectangle. Well, we know that the maximum area is going to occur when x is 1 over root 2, so we can just plug that back into our expression here for area. So we know that the area is going to be a maximum when we plug 1 over root 2 in for x. Okay, and if we simplify that all the way down, we get that the maximum area of the rectangle should be 1, and we'll just say units squared, 1 square unit, because we don't have units here. So that's our maximum area. Again, we plug it back into the original formula for that area there.